We are going to work on multiple, what they call multiple events, probability of multiple events. So that's going to include independent, dependent, and then mutually exclusive. And they can be related, and they're not terrible to do. So I'm going to give you a couple formulas today, but I'll try and give you a little couple ways to remember them. So just a couple definitions up here at the top. It just says two events are blank. These are going to be independent. So two events are going to be independent if they can, or the probability of one doesn't affect the probability of the other. Right? So independent, probability of one thing happening doesn't in any way affect the probability of a second thing happening. All right, now two events, excuse me, I can't speak, for the second blank are going to be dependent if the probability of one affects the probability of the other in some way. I got a couple examples. So independent, two things happening, but the probability of one in no way affects the other. Dependent means the probability of the first thing happening in some way changes the probability of the second thing happening. Okay, so a bunch of the questions on the Math Excel today, you guys will see, they'll just be multiple choice, like tell me is this independent or dependent. So I'm just going to use I for independent and D for dependent on those little lines because I'm lazy. Okay, if I flip heads on one coin and flip tails on a totally separate coin, so two coins, I'm going to flip both of them.
Yep.
I'm just asking if it's independent or dependent. So what I get on one coin affects what I get on the other coin when I flip it?
No.
So these are independent. Very good. You're right, it'd be half chance on both. Independent. So if I flip, what I flip on the first coin doesn't in any way affect what I flip on the second coin. Okay, now the second example here says just independent or dependent. A blue marble is chosen from a bag and set to the side. Go ahead.
Independent.
Okay, why?
Because it's set aside, so it's taken out.
Exactly.
It's taken out of the probability.
Exactly. So if you, almost always to kind of define this, if you have a dependent event, if you draw a marble or draw a card or takes it and they say, okay, we're going to set it aside or you can't use it again or whatever, that's a clue to you to know that it's dependent. Because if I take a marble out of the bag, now I have one less marble in the bag, so that would affect the probability of the second, which is choosing a green marble. Okay, now my last little independent or dependent, it just says you roll a 5 on a die and you spin blue on a spinner. And they're two separate things. One's a die, one's a spinner. They're not connected to each other in any way. So that would be independent. Okay, anybody have a question? All right, now, probability of independent events. So this just says probability of two independent events. So these don't affect each other. A and B are going to be what they use for the probability. If you see the word and with a probability, I want you to think multiply, because that's what you're going to do. You're going to multiply the two numbers together. And remember, whenever you do a probability, it has to be between 0 and 1. And so it should not be any number larger than 1 unless you're referring to it as a percentage. But this would be probability of A times the probability of B. But if you're doing an and statement, probability of this and this happening, you're going to multiply those two probabilities together. Okay, so I'm going to give you just a couple of, these are independent. That light just turned on. Okay, this says I have two separate bags, right? And I'm just going to write, you don't have to rewrite this, it's in the directions. But it says bag A has 9 red marbles and 3 green marbles. So I have a bag. This is totally normal for me to just have a bag of marbles, I guess. I don't know. But together there'd be 12 marbles in the bag, right? All right, now it says bag B has 9 black marbles and 6 orange. Again, this seems like a totally normal thing to have, you know, just a bag of marbles. Okay, now it says find the probability of selecting a green marble from bag A and a black marble from bag B. Okay, I've got two separate bags. It doesn't say anything about we're going to take 2 out of bag A, or it doesn't say anything like that. So we're not affecting each other when we do this. So I literally just have to do probability that I draw, let's see, green out of the first one. So probability of green out of the first one, how would you set that up? If I take a green marble out of the first bag, what would the probability of that be? 3 out of 12. All right. What would the probability I get, what's the second one? A black marble out of the second bag? 9 out of 15. They're just 2 totally separate bags, and you just multiply those 2 guys together. Now, remember, if you are multiplying fractions, you don't need a common denominator, but honestly, if I was doing this, I would just do it on my calculator, and you don't even have to reduce it. Like, both of those reduce. I'm just being super lazy here and using my calculator because I can. All right, now, anytime you do a probability, it should be between 0 and 1, so this would be 0.15. If you want to change it to a fraction real quick, because I think the Math Excel kind of spins into different ways they want you to write it. So I could just do that math, enter real quick. That'll convert it to a fraction, be 3 over 20. Or another way you can write it is the percentage. If I was doing the percentage, I would just look back to the decimal. If you just take that decimal, multiply it by 100, or you could scooch the decimal place 2 spots, that would be 15%. All 3 of those are correct answers for that. There's just sometimes different formats. The questions will ask you to put your answer in. So just make sure you're familiar with how to do all of them. Okay, now this also independent. The second question says 2 seniors, 1 from each of 2 government classes, randomly selected to travel to Washington, D.C. Says Wes is in a class with 18 students. So Wes's class has 18 people, and it says Emma's class has 20 people. Find the probability that both these 2 specific people get selected to go on this field trip. So what would be the probability that I draw Wes out of his class to go on the field trip? Go ahead. 1 out of 18, like, right, he's 1 kid out of 18 total. What's the probability I would draw Emma out of her class? 1 out of 20. All right, now this will, you guys will see, this will be a really, really small number. Okay, so this would be very unlikely that these 2 specific kids would go on this trip together. All right, so 1 out of 18, 1 out of 20. And then this has got 2 zeros in front of any numbers in this decimal. So I'm going to actually go out on this 4 decimal places so you can see it better because it's such a small number. Now, if I do my math, enter, and get that as a fraction, that would be 1 out of 360. If you did this as a percent, this is a super, super tiny number. If you do this as a percent, you'd scooch your decimal place over 2 spots. It would not even be 1%. It would be 0.28 as a percentage. Super small likelihood that these 2 people would specifically be chosen out of their classes to go on this trip. Is anybody having a question about the multiplying for and statements? Okay, now the probability of dependent events with your and is very similar. We're going to multiply again. So anytime you see the and, I want you to think multiply here. Multiply these. If you have a dependent event, remember the probability of the first event happening somehow affects the second probability happening. So what you want to do, you can do probability of your first event. It's just labeled as A for the whole formula here. And then we're going to multiply that by probability of B, but assuming that our first event A, happened. So it's going to be a little bit altered. If your dependent event, something that's done in that first event somehow affects the second event's probability. So you want to take just regular probability of the first thing, then multiply that by the probability of the second thing, but assuming the first thing happened. Okay. So here's my little example here. It says in a jar we've got 8 purple marbles, 10 yellow marbles, and 12 pink marbles. So if you just add those together just real quick to get the total, you have 30 marbles there. Just adding 8, 10, and 12. So there's 30 total marbles in this jar. Now, these are going to be dependent events because as I read through this question, you're going to draw a marble out of the jar, but you're going to keep it. So when you keep it, that alters the probability of the second thing happening. That's why these are going to be dependent events. So this says, if you take a marble from the jar and keep it, that's the part that makes it dependent. Your friend takes a marble from the jar after you. We're going to calculate this probability. It says, what's the probability you choose a purple marble and then your friend, after you're going to assume that you grabbed a purple one, then what would the probability your friend chose a yellow marble be? Okay, so what would be the probability if I just randomly walk up to this jar and draw a purple marble? What would that probability be? 8 out of 30. Okay, now think about this before you say it. You're going to assume that that's what happened. You drew a purple marble. Now, if your friend goes up to that same jar, you took a purple marble out. What's the probability your friend would then draw yellow? Sweet. All right. Except you meant 10, right? Because you just told me that for pink. Right? Yellow? You're good. Okay, so there's 10 yellow. All right, but since you took a marble out of the jar, now there's only 29 in the jar. So it changes the probability of the second thing because I have kept one and removed it. So now there's only 29 total. There's still 10 yellow marbles because we're assuming you did purple with your draw. Okay, now I'm just going to grab my calculator. So it'd be 8 over 30. I know I can reduce that, but I'm just being lazy. And then 10 out of 29. Whoop. Just multiply those together. Okay, most of the time the little math Excel is going to ask you to go 3 decimal places, so that's what I'm going to try to do here. So this would be 0.092. If you do have to convert it to a fraction, just 2 steps, just hit the math button and hit enter twice, and that'll convert it to a fraction for you. Or if you want to do that as a percentage, I'm just going to scooch that decimal place over 2 spots. So that would be 9.2 as a percentage. All 3 of those answers are possible ways you could express that answer. Okay, now this is a little different, so think about this before you answer it. The second part of this question, so same jar, same marbles, says what's the probability both you and your friend would draw a purple marble? Okay, so me drawing the purple marble, right, on the first draw would still be the same as the previous question. Now, remember, you're going to assume that that first person drew a purple marble. So what is now the probability of the second person also would draw a purple marble? Good. 7 over 29. You have 1 less purple marble because you're assuming that you drew 1 out. So now there'd only be 7 left. And then also, you took that marble out, so there's 29 marbles in the jar for them to draw from. All right, so then I'm just going to multiply those 2 guys together again. So I'm just going to do 8 over 30, 7 over 29. Okay, so a couple decimal places here. I'll go 0.064. If you do that math, enter, it'll make it a fraction for you if you need that. So 28 over 435. And as a percentage, you can just scooch that decimal place over 2 spots. Should be about 6.4% chance that that would happen. Is anybody having a question? Okay. Now, this one's not going to specify one way or the other, so we'll have to determine whether these events are dependent or independent. Okay, and forgive me, the very top right here, I don't know if you guys, this is not the greatest size for the spinner here. There should be a little B at the top, and I think when I copied it, it cut it off. But what I was trying to do was label the 2 events that it's going to ask you in this question about so you can see it on the spinner without spending a bunch of time trying to read it because it is kind of small. So this is like a Wheel of Fortune type spinner. And it says you spin the wheel, pictured there, and we're going to spin it twice. Then it says, what's the probability your first spin is worth more than 500 and then your second spin ends up being a bankrupt? It tells you there's 24 total spaces on this wheel. Okay, would these 2 things be dependent or independent? I'm going to spin the Wheel of Fortune wheel twice. These are independent. Okay. Why not dependent? Exactly. It doesn't say, I don't know if you guys, my grandma watches Wheel of Fortune. long time. Anyway, but sometimes they tell it like they'll pick the piece off the wheel or something. It doesn't say anything like that, so the wheel would be exactly the same. So the probability of the first does not affect the probability of the second. No, that's Jeopardy. Yeah, Alex Trebek. Pat Sajak is alive and well, as far as I know. Now that you've said that, that's probably not good for him today. Okay, anyway, now here's what I did. Just so you guys wouldn't have to read it, every single one of the spaces that is worth more than 500, I put a little A next to, like probability of A, if that makes sense. So there are, let's see, 1, 2, 3, 4, 5, 6, 7. There's 8 spaces that have a value that's more than $500. So that'd be 8 out of 24 for my first spin. And then this is where it cut it off. I tried to put a B for both of the bankrupts. They're just right top and bottom of the lovely wheel there. So there'd be 2 of those on the wheel out of 24. Okay, now don't add these because I think sometimes when things have the same denominator, people just automatically do that for some reason. So we're going to multiply these. Anytime it's probability of something and something else, it's multiplication. Now, this is going to look really similar to one we did on the front, but this is actually not as small of a decimal. There's just 1 0 in front of the 2. The one we did on the front had 2 of them. So, as a fraction, this is 1 over 36. And again, if you want to write it as a percentage, I'm just going to scooch the decimal place on my decimal 2 spots as a percentage. That would be 2.8%. So that one was independent. Okay, now my second question is going to deal with like a deck of cards. So just normal deck of cards, says 52 card deck, no jokers, anything like that, nothing weird. So it says you randomly select 2 cards from a standard deck. Okay, what's the probability the first card is not a face card and the second card is a face card? Okay, so let me just ask you before we start, even read the rest of the questions, because not always familiar with decks of cards all the time. So face cards are a jack, a king, and a queen. Does anybody know how many face cards would be in a normal deck of cards? There's 12. So there's the king, the queen, and the jack in each of 4 suits. So there's 3 of them in each, and there's 4 suits. So there's 12. Okay, now, just for this problem, so I have this. There's 12 face cards, and where am I going to put this? All right, so non-face card, which is what the first part of the probability asks you for. A non-face card would be like ace 1, 2, 3, 4, or sorry, not 1. Ace 2, 3, 4, all the way up to 9. So the rest of the deck is the face cards. There's 52 total. So non-face cards would be the rest of the deck. So to add up to 52, there would be 40 cards in a deck that are not face cards, would just be numbers, like ace, 2, 3, 4, 5, 6, 7, 8, 9. There's 40 of those. Okay, now, my first question, these are 2 different questions, the same thing. The first question says you replace the first card and then draw the second card. And then this one says you don't replace the first card. So if I randomly draw a card out of a deck and I hold it, or no, I'm sorry, I'm going to put it back. It says you replace the first card. So if I'm going to draw 2 cards, I take the first one and I hold it out. Would that, or no, oh my gosh, I put it back. Is that going to be dependent or independent for this first one? If you put it back, it's independent because the probabilities each time are both equally likely. If I don't replace the card, which is what the second part of this says, if I don't replace it, if I hold it out, then that is going to affect the probability of my second draw, so then that would be dependent. Okay, now, so probability I don't draw a face card on my first draw. There's 40 of those, so it'd be 40 out of the cards, 52 in the deck. And then on my second draw, I do draw a face card. That would be 12 out of 52. I'm assuming that I'm going to draw a non-face card on the first draw. So that would be the 2 fractions I would multiply together. Those would be my 2 probabilities. All right, so I'm going to do 40 out of 52, multiply that by 12 out of 52. All right, so like 0.178, maybe if I go 3 decimal places. If you want to do fraction, math, enter, it's 30 over 169. And if you want to do percent, I'm going to scooch that decimal place over 2 spots, so it'd be 17.8%. Okay, now, if I draw the first card out and I hold it, that's going to change the probability of the second thing. So, still 40 out of 52 for my first draw. What would the probability then be that I draw a face card on the second draw? How would that be different? I'm assuming I did not draw a face card. Otherwise, you're like doing the wrong part of the fraction. I'm going to draw a face card on the second one. 12 over 51. Okay, so when you do that, you're going to assume you did not draw a face card on the first one. So I didn't draw one, so that all 12 should still be in the deck. But if I held the card out, that would change the bottom number because now there would only be 51 cards left for me to select from. So that one's really tricky. So just do 40 out of 52, and then the second one would be 12 out of 51. So this one, about 1.181. If you want to do the fraction, that's going to be 40 out of 221. If you want to do the percent, that's going to be 18.1%. Now, honestly, I know I keep doing all 3 of those on the answers here. You guys don't have to do that. I'm just doing that. So if you run into that on Math Excel, hopefully you can do that pretty quickly and convert between those different formats. Okay, and then you guys will see, I crossed off this little example too. I just want to kind of explain this real quick to you instead of doing that. So if you want to cross that off, you can, but it's going to be related to this next definition here. All right, so 2 events are what we call mutually exclusive. 2 events are mutually exclusive if it would be impossible for them to happen at the same time. So it says 2 events are mutually exclusive. They cannot happen at the same time. Okay, so just as a couple little examples. The 3 examples that I have here, these are all mutually exclusive. If you roll a die, it would be impossible for you to roll a 2 and a 3 at the same time. Mutually exclusive. That can't happen at the same time. If I have to pick between a dog or a cat, I can't pick 2 different animals at the same time if I only have to pick one. It's one or the other. If I draw a card out and it says I can't choose a heart and a diamond at the same time, they're 2 different suits, that wouldn't be possible. Now, these are not mutually exclusive over here. These can happen at the same time. So if I roll a die and I get a 2, it says I can roll a 2 and an even. Since 2 is an even number, those 2 things can happen at the same time. If I choose a dog and a poodle is a dog, so my dog choice there could be a poodle, and that could happen at the same time. And then the last one, a heart and an ace, there's an ace of hearts. So if you choose a heart, one of those is an ace. So those 2 things can happen at the same time, so they're not mutually exclusive. Okay, now what I'm just going to write this down for you guys here. People confuse this sometimes. This says independent equal to mutually exclusive. No. Independent can happen at the same time. Mutually exclusive cannot happen at the same time, but independent can happen at the same time. Like I could, draw a card and flip a coin. Those are 2 things. They're not affecting each other, but they could happen at the same time. Right? Mutually exclusive cannot happen at the same time. Now, I kind of have 2 different formulas here for these, but we're going to switch into some or statements. All right. So this is going to be probability of A or B. If you see or, I want you to think that you're going to add those probabilities together. A or B, we're going to add the probabilities together. Okay, now, in general, this is a little bit longer of a formula. Probability of A or B. It's the probability of A plus the probability of B, and then I'm going to write minus probability of A and B. And what I'm doing with that, which I think will make a little bit more sense once we do a couple of these examples, basically you're subtracting out any overlap that maybe you would count. And the probability of A and the probability of B, maybe there would be some overlap if they're not mutually exclusive. So you're going to subtract out the probability that they would both happen at the same time. I promise this will make more sense in a second when we do the examples. Okay, now, if the two events can't happen at the same time, they're mutually exclusive, this would just be probability of A plus probability of B. There's no, because they would not have an overlap, so there wouldn't be anything to subtract out. Okay, so I'm just going to ask you whether you think these are mutually exclusive in this example, and we're going to calculate the probability. So it says about 30% of the people in the United States are under 20 years old. You would fall into that category. I would not. Okay. About 17% of the people in the population are over 60. Which one? Oh, no, I'm not in that category either. Okay. I'm in the middle. All right. Thank you. That hurt my feelings. Whatever, it hurt my feelings. I'm crying in my head. Okay. What's the probability a person chosen at random is under 20 or over 60? So I'm going to randomly pick somebody. What's the probability they're under 20 or over 60? Can those two things happen at the same time? No, you can't be under 60 and over 60 at the same time. So these would be mutually exclusive. They cannot happen at the same time. So if they're mutually exclusive, I literally just have to add the probabilities together. Okay, now, probability, what? It is 47. So 30% chance the person would be under 20, 17% chance they'd be over 60, 47%. If you prefer, you could convert that to a decimal, it'd be 47%, as be 0.47 as a decimal. But those are mutually exclusive because you can't fall into both of those categories at the same time. Okay, now, see what you think here. This says I'm going to just throw a die. All right, number cube is what they call them sometimes. Probability that it's a 3 specifically or an odd number. Would you say those are mutually exclusive? So can I roll a 3 and an odd at the same time? Yeah, because 3 is an odd number. Okay, so this is not mutually exclusive, so there will be an overlap. Okay, now you don't have to do this, but this is how I kind of do it. So probability of the first thing happening, right, would be a 3 or an odd number. So if you have a die, odd numbers would be 1, 3, and 5, right? So probability of the first thing happening would be 1/6. Probability of the second thing happening, this is an or statement, we're going to add these together, would be 3 out of 6. What overlaps there? The 3, right? Do you guys see how there's a 3 in both categories? So basically what I'm saying with that overlap, I counted that twice. Like I counted 3 twice in that mix. So what I have to do is subtract off that extra time I counted the 3. That's what the overlap would be. That's what's going on in this little formula up here. So probability of A, probability of B. A and B can happen at the same time because they're not mutually exclusive, so I got to subtract that out. This is basically the 1/6 here, 1/6 subtracted here would cancel each other out. So you're going to get 3 over 6. So this would be a 50% chance. If you rolled a die, you would get a 3 or an odd number. All right, so I'm just going to write out my options for this one. We'll decide if it's mutually exclusive. Okay, even number. So on a die, 2, 4, 6. Or a number less than, it does not say less than or equal to, it just says less than 4. So numbers less than 4 on a die, 1, 2, 3. Okay, mutually exclusive, yes or no? The 2 is an overlap. So these are not mutually exclusive. So this is not, they can happen at the same time. The 2 would be the overlap. So if I'm doing my probability, this one would be 3 out of 6. This one would also be a 3 out of 6. But I counted that 2 twice. So that's your overlap. So you just subtract out one of the two since we counted them twice. And so remember, your probability should not be more than 1. It has to be between 0 and 1. So just keep that in mind. So add this up here. This should actually just give you 5/6 as your 83.3 repeating percent. Yes. Okay. Now, this last one, I feel like I got a lot of questions on the homework about what a prime number was. So I know you guys know what odd numbers, so like 1, 3, 5. Do we know what is a prime number? 9 is not a prime number. 2 is though. Wait. Go ahead. Right. Okay, so you can't basically the only factors of the number, the technical definition, are 1 and the number. So there's not another set of numbers. So like 9, I could do 3 times 3. 8, I could do 4 times 2. 7, I can only do 1 times 7, so that's a prime number. 5, you can only do 1 times 5. So 3, you can only do 1 times 3. 13, you can only do 1 times 13. Now, 2 is the only even prime number because 2's only factors are 2 and 1. But pretty much any other even number after that, like if I had 26, that's 13 times 2. Or if I had 28, that's 14 times 2. Any other even number should not be prime. There are other odd numbers that are not prime. Trying to think of like 15 is not a prime number because you can do 5 times 3. It has to just be the factors would only be 1 and the number to be prime. Okay, now, if you guys see here, this is for sure not mutually exclusive because 3 of those numbers, the 1, 3, and 5, actually fall into both of those categories. So this is for sure not mutually exclusive on this question here. Okay, now, this would be 3 out of 6. Prime number would actually be 4 out of 6, but I counted the 1, the 3, and the 5. So there overlap there. I counted all of those twice. So there's 3 numbers I counted twice. So my overlap would be 3, 6. So actually, this will be real quick. These two would just cancel each other out. So you'd have 4/6, or if you want to reduce that, 2/3, which would be 66.6 repeating percent as a probability. Does anybody have a question? Now, the last two are just real quick. There's a couple questions on the Math Excel they're going to give you. They're just going to say these two things are independent or mutually exclusive or something, and they're not actually going to give you a situation. They're just going to tell you this is the probability of A and this is the probability of B. So you got to remember what these mean. All right, so independent events, if you're going to do probability of A and B, all that means is I'm going to multiply the two probabilities that they give me. If you have an AND statement, you're just going to multiply. So if I'm doing probability of A and B and they give me those probabilities, we would just take, for this example, 1/6 times 2/5 would end up being 2/30, which is 1/15 as a fraction. And then we could do the decimal and the percentage, but I'm just going to try and save some time. Okay, now, mutually exclusive, if you see that, then we don't have to worry about like what we were doing in the last example of any kind of an overlap. So there's no overlap there. So if you don't have an overlap and you're going to do here an OR statement, if you have an OR statement, all you have to do is add the two probabilities together. So it says probability of C is 1/2, probability of D is 3/8. So if it's an OR statement, we're just going to add those together, 1/2 plus 3/8. And I'm just going to cheat on my calculator real quick because I'm lazy. And what is this? This would be 7/8 as a fraction, 0.875 as a decimal. Is anybody having a question about the independent, dependent, mutually exclusive? If you can remember AND is multiply, OR is add, you'll be in good shape. The homework is going to be on Math Excel.